Good morning, dear students. Today we are going to teach you Math for Junior 6. We are going to study together Unit 1, Lesson 2. Unit 1, Lesson 2 is about factorizing a number in its prime factors, knowing how to find the GCF and the LCM. First, we are going to talk about prime numbers. What are prime numbers? Prime numbers are numbers that has only two factors, that is 1 and itself. Having an example of 2 as a prime number, we find that 2 is a product of the two numbers 2 and 1. So 2 has only two factors, that is 2 and 1. 3 also has only two factors that are 3 and 1. 3 times 1 equals 3. So it has three factors, that is 1 and 3. Any number that has its two factors, 1 and itself, is called a prime number. So 2 and 3 are prime numbers. Let's look about the other prime numbers. We find that the smallest prime number is 2. And it is the only even prime number. All the other prime numbers are odd. The smallest odd prime number is 3, and the smallest even prime number is 2. We have also 5, 7, and 11 as prime numbers, because each one of them has only two factors, that is itself and 1. Talking about composite numbers, what is a composite number? A composite number is a number that has more than two factors. More than two factors. Taking an example with 12, we see that 12 has factors like 12 times 1, 6 times 2, 3 times 4. So 12 has 6 factors, which is 2, 1, 3, 4, 6, and 12. So we say that 12 is a composite number. It is not a prime number because it has multiple of factors. It is a composite number. By this, we finished studying prime numbers and composite numbers. Let's see what we have now. We are going to start something called prime factorization. Prime factorization is writing a number in its prime factors. Write a number as a product of its prime factors. We find that 24 is composite of two factors, that is 2 and 12. To factorize a number, first we start by asking it a question. Are you even or odd? 24 is an even number. So we start dividing it by 2. We said that the prime numbers are 2, 3, 5, 7, 11, and etc. We start with 2 because 24 is a prime number. So 24 can be factorized to 2 and 12. 2 times 12 equals 24. Still, 12 is an even number. It can be divided into 2 times 6. Also, 6 can be divided to 2 times 3. So we can write 24 in its prime factors that are 2 and 2 and 2 and 3. We write here the first 2 and 2 and 2 and 3. That is the prime factorization of 24. Writing 24 as the product of the prime factors we get from the prime factorization. We write 24 equal 2 times 2 times 2 times 3. Okay, that is prime factorization. Let's start to have some examples to make prime factorization together. We'll start first with 36. We will ask it our question. Are you even or odd number? You say, I ends with a 6, so I'm an even number. Any number that ends with 0, 2, 4, 6, or 8 in the units place, it will be an even number. So we can divide it into 2 and 18. 2 times 18 equal 36. Again, 18 as an even number. So we divide it into what? Into 2 and 9. 9 is an odd number, so we stop trying to factorize with 2, and we will factorize with 3. Here we will write the right numbers up to remember them. Write 2, 3, 5, and 7. So we can factorize 9 into 3 and 3. Now we write 36 as 36 equal 2 times 2 times 3 times 3. We factorize this 36 into 2, 2 times 2 times 3 times 3. These are the prime factors of 36. By doing this prime factorization, let's move to the other question, which is 28. 28 is also an even number. I divided by 2. 2 times 14 equals 28. 14 equals 2 times 7. We will stop here because 7 is a prime number, 2 is a prime number, and 2 is a prime number. So that's the prime factors of 28. Let's write out factorization line. It will be 28 equal 2 times 2 times 7. 2 times 2 times 7 gives us 28. That's my prime factorization line. Let's move to the last question. Factorizing 48. We will write 48 and start factorizing it. Are you even or odd number? An even number. I can be divisible by 2. So I'll divide it into 2. 48 equal 2 times 24, correct? 24 is still an even number. It can be divisible by 2. It gives me 2 and 12. I still can divisible by 2. It gives me 2 and 6. I can divide it again by 2. It gives me 2 and 3. So I write 48 equal. So the prime factors of 48 is 2 times 2 times 2 times 2 times 3. I start to write here the line of the prime factors. Who can tell me what shall we write now? We write 2 times 2 times 2 times 2 times 3. Very good. By this, we made our prime factorization for 36 into its prime factors. We made the factorization of 28 into its prime factors, and the factorization of 48 into its prime factors. Let's move to another one. Try to solve it yourself, and we'll check it together. Let's start solving these examples. We'll start with this number, 45. Is it even number? No, it's an odd number. It cannot be divisible by 2. So I'll try divisible by what? By 3 or by 5. So 45 is in the table of 5. I'll divisible it by 5. It will be 25 and 9. I still can factorize 9 into 3 and 3. I can write 45 equal 5 times 3 times 3. That's my factorization line, my prime factorization line. To solve this one, 30, I divide it into, divided by 2, it will give me 15. Divided by 3, it give me 5. So I can write it as 30 equal 2 times 3 times 5. That's my prime factorization. 30 is equal to 2 times 3 times 5. And I write it on this line, which is called the prime factorization of 30. Let's factorize this 16 into 2 times 8. I make circles only on the prime numbers, okay? 8 is divisible by 2 again, and 4. Still 4 can have 2 times 2. So I write it 16 as its prime factors, which is 2 times 2 times 2 times 2. That's my factorization number. So the 16 is factorized into 2 times 2 times 2 times 2. And I write my factorization number, prime factorization here. Now we are moving to another definition, which is the GCF. What is the GCF? What is the GCF? It is the greatest common factor. The greatest common factor, it is the GCF. Means that I will find the greatest number that is a factor of both numbers. Let's see. If I'm dealing with two numbers, that is 18 and 24. 18 and 24. Giving me a question, find the GCF. I'll try solving it with my first method, which is called prime factorization. My first way is prime factorization. I start making my factorization, and for 18, it gives me 3, 2, and 3. I write it here. 18 equal 2 times 3 times 3. Here, the line of prime factorization of 18. After that, I write the factorization for 24. 24 give me 2 and 2 and 2 and 3. I write it here in the second line as the prime factorization of 24. So I write two lines, line of prime factorization of 18 and the line of prime factorization of 24. After that, I take the common between them. I find that this 2 is a common factor, and this 3 is a common factor also. So to find the GCF, I multiply this common factor, which is 2, by this common factor, which is 3, and it gives me a 6. So my GCF is equal to 2 times 3 equal 6. 2 times 3 equals 6. Stop. Is there another way to solve the GCF? Yes, there is another way. What is this way called? It is called the Venn diagram. What is a Venn diagram? Drawing a circle and another circle intersecting in an overlapped area. Having two circles intersected together in this area, I can write and solve the GCF also by another way, which is called Venn diagram. By doing this, first I'll factorize 18 into its prime numbers, which is 2, 3, and 3. And I'll factorize 24 into its prime numbers, which is 2, 3, 2 times 2. After that, I'll draw these two circles. I try having the numbers in common. What are the numbers in common? Yes, the numbers is common. It's the 2 and the 3. So I write this 2 here and this 3 here in the intersection area of the two circles. Multiplying 2 times 3, it gives me 6, which is the GCF. So the intersection area here of the two circles give me the GCF. That is how I represent the GCF in the Venn diagram. Still, I can find this here as 3. Where can I put this 3? I'll put it here in the side of the 18. In the part of the circle that is not intersected, and in the side of the 18. These two and these two related the 24. I'll put it here, 2 and 2 in the area of 24. Okay? Again, we will say that to solve the GCF in the first method, which is called prime factorization, I find the common factors between the two numbers, which is 2 times 3 equals 6. By this, I find the GCF. That's my first way, which is called prime factorization. In the other method, which is called Venn diagram, I draw two circles intersected together, and I start finding the prime factors of 18 and 24, writing them into two lines. After I write these two lines, I start putting the common factors here, which is 2 and 3. I put it here in the intersection area, and I calculate the GCF from these two numbers. 2 times 3 equals 6, so my GCF is equal to 6. And find that there is 2 2's here in that 24. I'll put it here in the 24 side of the circle. And in the side of the 18, we put this 3. So by this, I represent my Venn diagram. This is the circle of 18, and this is the circle of 24, and this is the intersection area, which is the GCF. Okay? By this, I found the GCF by another method. Let's see some examples. Before we will see the example, we will talk about something called the LCM. What is the LCM? It is the least common multiple. LCM means the least common multiple. Let's see what we can do. Again, we are dealing with the two numbers, 18 and 24. This is the 18 and this is the 24. I'll start making my factorization. And I write the 18 in this line. And I write 24 in this line with its prime factors. I write the 18 in its prime factors, which is 2, 3, and 3. So 18 equal 2 times 3 times 3. And 24, I'll make the prime factorization here and write it as 2 times 2 times 2 times 3. And I write this line. I'll start finding the commons. I'll find 2 in common and 3 in common. Okay, I'll take only one. From these two, I'll take only one and I'll put it here. From these two 3's, I will take one and put it here. After that, I'll see that I have numbers that is not repeated. This 3, I'll put it here. And these 2's, I'll put it here also. So how can we calculate the LCM? How can we calculate the LCM? The definition of the LCM says it is the product of all prime factors. The product of all prime factors. So I'll multiply all the prime factors, which is 2, 3, 3, 2, and 2. So 2 times 3 times 3 times 2 equals 72, sorry. So the LCM is equal 72, which is the multiple of 2 times 3 times 3 times 2 times 2. By this, I find the GCF, the LCM. Do I have another method to find the prime factorization? Yes, I have another method. My first method was the prime factorization. My second method will be the Venn diagram. Again, I'll draw my circle, two circles intersecting together in an area of overlap. And I'll start factorizing the 18 and the 24 into two lines. I'll put it here, 18 as 2 times 3 times 3. 24 as 2 times 3 times 2 times 2. I'll find the numbers in common. It will be 2 and 3. Go and draw them in the circle. I'll put them where? In the intersection area, the 2 and the 3. And I'll find the difference number. This 3 related to the 18, I'll put it here. This 2 and 2 related to 24, I'll put it here. So I draw the factors of 18 and 24 in the Venn diagram. Here I put the GCF, the common factors, and I put the other factors. And then I calculate the LCM, knowing that the product of all prime factors in the Venn diagram. So I'll multiply 3 times 2 times 3 times 2 times 2. It gives me 72. So I find the LCM by two ways. First way, to make the prime factorization, write the two lines and multiply the factors. Second way is the Venn diagram, drawing the two circles, writing the two lines of prime factorization, taking the common and put them in the intersection area, writing the other factors here, and multiplying all the prime factors to have the LCM to be 72. Let's have an example. I'll start first factorizing the 8. 8 will be 2 and 4. 4 will be 2 and 2. Factorizing the 6, it gives me 2 and 3. Writing the two lines, 8 equal 2 times 2 times 2. I factorize 8 into 2 and 2 and 2, and I put them in this line. I factorize 6 into and 3, and I write it in the other line. Writing the GCF and the LCM. What is the definition of the GCF? The GCF is the common factors. So I write here the common factors to be 2. So the common factor is 2. And the LCM is 2 times what? I'll take the difference numbers. So I can take this 2 and this 2 and this 3. I write them here. Times 2 times 2 times 3. They give me 2 times 2 times 2. It is 8 times 3. It is 24. So I calculated the GCF to be 24. The GCF to be 2 and the GCF to be 2 and the LCM to be 24. Again, we can deal with this other example. $12 and 16, making my prime factorization of 12. I found that 12 is an even number, so I divide it into 2 and 6. Again, I can divide it into 2 and 3, correct? I write it as 12 equal 2 times 2 times 3. So I make prime factorization to 12 into 2 times 2 times 3. I write it in this line. Then I go to factorize again the 16 into 2 and 8. Factorize 8 into 2 and 4. Then factorize the 4 into 2 and 2. I write the 16 as 2 times 2 times 2 times 2. Putting the line, writing the GCF to be the common numbers. What are the common numbers? The common factors between them, I have these two and these two. So the common number is 2 times 2. It is a 4. Trying to have the LCM, it will be 2 times 2. I'll take one of these 2's and one of these 2's. Then I will multiply by the 3 and the 2 and the 2. So times 2 times 2 times 3 equal 2 times 2 gives me a 4. Times 2 gives me 8. 8 times 2 times 3 gives me 6 and this is 12, 24, 48. So by this I find the GCF to be equal 4 and the LCM to be equal 48. I solve it my GCF and LCM for this example. Okay. Let's take this as a homework and we will see it next time. Okay. Solve the LCM and GCF for 10 and 15 and 25 and 28 and we will see it next time. Okay. Now we are moving to another name, which is relatively prime number. What is a relatively prime number? If I give you two numbers and you find no common factor between them, except one. The GCF here is equal to 1 and the LCM is equal to their product. So these two numbers are called relatively prime numbers. Let's have an example for these numbers. Having a number like 8 and 9. I make factorization to 8 into its prime factors. It gives me 2 and 2 and 2. 8 equal 2 times 2 times 2. Making factorization to the 9, it gives me 3 and 3. So I can write here 9 equals 3 times 3. Trying to find the common between them, I find nothing. So I leave this area, this intersection area empty. This means that the GCF is equal to 1 because only 1 is inside this 8 and only 1 is inside this 9. Okay? And they have no common factor between them. Okay? So we can say that 8 and 9 are relatively prime numbers. That is the definition of relatively prime numbers, that are numbers that don't have a common factor between them except 1. Their GCF is equal to 1. Their LCM is equal to their product. If I draw them in the Venn diagram, this area will be empty. I write the factors of 8 in this side of the circle. 2 times 2 times 2. I write the factors of the 9 in this area of the circle. 3 times 3. By that, they are known as relatively prime numbers. Very good. Try to solve this example. He asked me to find the GCF and the LCM for 4 and 9, and to decide whether they are prime, relatively prime numbers or not. So I have 4 and 9. 4 is factorized to 2 times 2. 9 is factorized to 3 times 3. Writing my two lines, 4 is equal to times 2. 3 is equal to 3 times 3. GCF, I have nothing in common, no common factor. So the GCF is equal to 1. And the LCM is equal to their product, which is what? 4 times 9 equals 36. So from this factorization, I can see that there is no common factor between 4 and 9. So I can write that the GCF equal to 1. The LCM is equal to 36. And I can draw this in the Venn diagram like this. A circle and a circle intersecting together. I will write nothing here because the GCF is equal to 1. I'll write the factors of 9 here, which is 3 and 3. I'll write the factors of 4 here, which is 2 and 2. So that is the Venn diagram for 4 and 9. And I can say that they are relatively prime numbers. They are relatively prime numbers. 4 and 9. Now we can have this as exercise for today for lesson, and I check them the next lesson, inshallah. So you can solve these questions and send me the screenshot of your answers, and I'll correct them for you next lesson. Thank you for now, and goodbye.